Hi, welcome to this walkthrough of Edexcel A-Level Pure Mathematics Paper 2 of June 2019. Along with this walkthrough, I would like to give one or two useful tips for your A-Level Maths exam. Please take some time reading the official marking schemes from your exam board. You'll be surprised at the rigor expected on the answer presentation and how students may be losing marks on exam technique flaws and incorrect statements in the paper rather than the mathematical correctness of your method or answer. Some common pitfalls that take away your marks are: 1. In not writing a logical statement at the concluding stage of the answer, such as therefore 4n square plus 1 is odd, or the function is a decreasing function, or therefore a particular point is a turning point, etc. The idea is never assume that your conclusion is obvious. Please make it clear. Another incorrect statement that might lose marks is saying logarithm of a number cannot be negative, whereas you should be saying we cannot take logarithm of a negative number. These incorrect statements actually lower your eligibility in the eyes of the examiner for high grades, which is what you are looking for. Okay, more tips in the next walkthrough. Now let's get on with the questions. Question 1. Given 2 to the power of x times 4 to the power of y equals 1 over 2 root 2, express y as a function of x. This question can be easily solved using the laws of indices. Let us rewrite the equation as 2 to the power of x times 2 to the power of 2y equals 2 to the power of minus 3 over 2, which means x plus 2y should be equal to minus 3 over 2. Making 2y the subject here, we have minus 3 over 2 minus x. Therefore, y equals minus 3 over 4 minus x over 2. So this is expressing y as a function of x. Question 2. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. The results are given in the table below with time in seconds and the speed in meters per second. Using all this information, estimate the length of the runway used by the jet to take off. So here our task is to calculate the length of the runway, which is the distance, and we have been given time and the speed at various intervals of 5 seconds each. So if you consider the velocity time graph, the area under the graph will be equal to the distance traveled. Since each of these has a fixed time interval of 5 seconds, we can use the trapezium rule. So the trapezium area rule goes like this: area equals half times height times y0, let's say y1, plus yn plus 2 times of y2 plus y3 plus etc. Close the bracket, close the bracket. So substituting the values here, we can write half times 5 times the first velocity was 2 and the last one was 42, in between 2 bracket 5 plus 10 plus 18 plus 28, close the bracket, close the bracket. Putting into the calculator, we get 415 meters. Another method of approximation of the distance could be by adding this u, which is 2, and the final velocity 42 divided by 2 multiplied by the time taken 25, and that will give you 550 meters. But that's also allowed because it's only an estimation here. Part B. Given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or an overestimate of the length of the runway used by the jet to take off. So going by this trapezium area method, it is an overestimate. So if we draw this sketch here, let's say this is the time axis, This is the velocity axis or speed axis this side. So when it is 0, it is 2. When it is 5, it is 5, and so on. So the curve might go like this, right? And therefore, if I put trapezium here, etc., you can see that a small part of the trapezium is above the curve. It's because it's a convex curve. So we could say an overestimate as the curve is below the top of the trapezia. Question 3. Figure 1 shows a sector AOB of a circle with center O, radius 5 centimeters, and angle AOB equals 40 degrees. The attempt of a student to find the area of the sector is shown below. Area of sector equals half r square theta, that is half 5 square 40, which is equal to 500 centimeters square. Question. Explain the error made by the student. Well, the student has used half r square theta, which is the formula for finding the area, using radians and not degrees. Because here 40 is in degrees, he should have first converted 40 degrees into radians before using this formula. Alternatively, the student should have used pi r square times 40 over 360, which is the applicable formula for degrees for calculating the area. So let's write. The student should have converted 40 degrees into radians. Part B. Write out a correct solution. So firstly, let us convert 40 degrees into radians. That's going to be pi over 180 times 40. That is equal to 2 pi over 9. Therefore, area equals half times r square times theta, which is equal to 25 pi over 9, which is also equal to 8.73 centimeters square in decimals. Question 4. The curve C1 with parametric equations x is equal to 10 cos t, y equals 4 root 2 sin t, where t is between 0 and 2 pi, meets the circle C2 with equation x square plus y square equals 66 at 4 distinct points as shown in figure 2. Given that one of these points, ES, lies in the fourth quadrant, find the Cartesian coordinates of S. So let's write at intersection points 10 cos t squared plus 4 root 2 sin t squared should be equal to 66. Expanding this, we get 100 cos square t plus 32 sin square t equal to 66. To solve this, we need to convert this into a quadratic in one trigonometric ratio. See, for example, we can write this as 100 bracket 1 minus sin square t plus 32 sin square t equals 66. This gives us 100 minus 100 sin square t plus 32 sin square t equals 66. Simplifying this, we get 100 minus 68 sin square t equals 66. Therefore, 34 equals 68 sine square t, leading to sine square t equals 34 over 68 or 1 over 2. Hence, sine t should be equal to plus or minus square root of 1 over 2. Therefore, sine t equals 1 over root 2 or minus 1 over root 2. Let's put the calculator into radian mode and calculate t equals sine inverse of 1 over root 2 as well as sine inverse minus 1 over root 2. This gives us pi over 4 or minus pi over 4. Therefore, the point S should be 10 cos pi over 4 for the x coordinate and 4 root 2 sine minus pi over 4 for the y coordinate, because it is in the fourth quadrant. That is equal to 5 root 2 comma minus 4. Question 5. Figure 3 shows a sketch of the curve with equation y equal to square root of x. The point P xy lies on the curve. The rectangle shown shaded on figure 3 has height y and width delta x. Calculate limit delta x tending to 0, sigma x is equal to 4 to 9 of square root of x delta x. This question is actually testing your knowledge to identify that this summation with limit delta x tending to 0 is actually the area under the curve, which can be found by integration between x is equal to 4 and x is equal to 9 as limits. The concept is that the area of this rectangle, which will be delta x times the y, which is square root of x, times delta x, that will be the area of one small rectangle, and if you add up all those rectangles, then that will be equal to the total area under the curve between x is equal to 4 and x is equal to 9. So let's write limit delta x tending to 0, sigma x is equal to 4 to x is equal to 9 of square root of x delta x is equal to integral between 4 and 9 of square root of x dx. So to integrate this, we will write this in the form of index. So 4 to 9 of x to the power of half dx. That's equal to, start with the square bracket, x to the power of 3 over 2 over 3 over 2. There is no need to write c because it's a definite integral between 4 and 9. That's equal to x to the power of 3 over 2 times 2 over 3. Now let's evaluate this. 9 to the power of 3 over 2 times 2 over 3. Take away 4 to the power of 3 over 2 times 2 over 3 equals, this equals 27 times 2 over 3 minus 8 times 2 over 3. That is 18 minus 16 over 3, which gives us 54 minus 16 all over 3, which is equal to 38 divided by 3 is equal to 12 3s are 36. Then you have got 2 over 3. Question 6. Figure 4 shows a sketch of the graph y is equal to g of x, where g of x is a piecewise function, x minus 2 whole square plus 1 when x is less than or equal to 2, and 4x minus 7 when x is greater than 2. Find the value of g of 0. Here our strategy should be, first we will find the g of 0 by putting 0 in place of x in the first function. Then based on what we get, we will determine that second value should go into this first function or the second function. So first let's find out g of 0. That is 0 minus 2 square plus 1, which is equal to minus 2 square plus 1 is 5. Since the new input is going to be 5, we need to use the equation g of x equals 4x minus 7. So we write g of 5 equals 4 times 5 minus 7, which is equal to 13. Therefore, g of 0 equals 13. Part B. Find all the values of x for which g of x is greater than 28. Let us first write both the functions of g of x. G of x is x minus 2 square plus 1 when x is less than or equal to 2, and g of x is also equal to 4x minus 7 when x is greater than 2. So taking the first function, x minus 2 square plus 1 is greater than 28. That means x minus 2 square is greater than 27. Expanding this, we get x square minus 4x plus 4 is greater than 27, leading to x square minus 4x minus 23 is greater than 0. This will not factorize easily, so let's use our quadratic formula. Therefore, x will be equal to, that is the critical value of x, will be equal to minus b, that is plus 4, plus or minus b square, that is 16, minus 4 times 1 times minus 23 all over 2. Therefore, x should be 4 plus or minus square root of 16 plus 92 over 2. Therefore, the critical value of x should be plus or minus square root of 108 over 2. Putting this into the calculator, we get 2 plus 3 square root of 3 or 2 minus 3 square root of 3. Since this is an inequality function, let us first of all sketch the diagram so that we can identify which values of x are the correct values. So here, this must be 2 minus 3 square root of 3, and this is 2 plus 3 square root of 3. Putting this into the calculator, we get the exact decimal value of minus 3.20 here and plus 3.20 here. We want the function value to be greater than 28, which means we want this area and this area, that is x should be less than minus 3.20 or x should be greater than 3.20. We can circle this off because the piecewise function domain very explicitly says that x should be less than 2 for that function to be valid. Therefore, this is our valid value of x. That is, x should be less than minus 3.20. Let us now use the second function to solve it. That is, 4x minus 7 is greater than 28, which means 4x is greater than 35, or x should be greater than 35 over 4. Therefore, the valid values of x are x should be less than minus 3.20, which is actually 2 minus 3 square root of 3, or x should be greater than 35 over 4. Part C. The function h is defined by h of x equals x minus 2 square plus 1, where x is less than or equal to 2. Explain why h has an inverse but g does not. Okay, so if you look at the curve here, in the case of g of x, it does not have a restriction that x is less than or equal to 2. It can be more than 2 also. Therefore, it's a many to one function. That means for more than one value of x, you will be getting the same value of y. which means it's a many to one function. For many to one functions, there is no inverse. Contrasting with this, the h of x has got this restriction, x is less than or equal to 2. So this part of that function is not there. So h of x is ending here, which means it's a one-to-one function. Hence we can say that it has got an inverse. H of x is a one-to-one function and hence has inverse. G of x is a many to one function. And hence does not have an inverse. Part D. Solve the equation h inverse of x equals minus half. So let's first of all find the h inverse of x. H of x equals x minus 2 square plus 1. Let's write let h be equal to x minus 2 square plus 1. Let's try to make x the subject. So h minus 1 equal to x minus 2 square, leading to square root of h minus 1 equals x minus 2. Therefore, 2 plus square root of h minus 1 equals x. At the moment where we get x on one side by all itself, then we will be writing h inverse of x equals 2 plus square root of x minus 1 by replacing the h with x. So now as per the question, this is equal to minus half. Therefore, square root of x minus 1 equals minus 2 minus half, or x minus 1 equals minus 2.5 square, and x equals 1 plus minus 2.5 square. That is, x equals 1 plus 25 over 4, which is equal to 29 over 4, resulting in 7/1/4. Question 7. A small factory makes bars of soap. On any day, the total cost to the factory, pounds y, of making x bars of soap is modeled to be the sum of two separate elements, a fixed cost and a cost that is proportional to the number of bars of soap that are made that day. Write down a general equation linking y with x for this model. So we can write the equation as y equals mx plus c, where c is the fixed cost and m is the constant of proportionality. And x is the number of soaps produced for the day. Next part of the question. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, show that y equals 0.84x plus 428. So we need to generate two simultaneous equations and derive the values of m and c from there. So let's list down the bits of information that we have. So when 800 bars of soap are made and sold, what will be the selling price? That will be 800 times 2. And then what is the profit? Let's write profit slash loss here. And that is going to be £500. And from there we can figure out what is the cost price. Okay. And then when 300 soaps are made and sold, then the price will be 300 times 2, and then there is a loss of 80 here. So from this we know 1600 minus 500 will be 1100, the cost price. In this case 600 plus this 80, because it's a loss, that should be the cost price, that is 680. So from this we can write the cost price 1100 is equal to m bracket 800 plus the fixed cost C, and when the cost price is 680, m bracket 300 plus the fixed cost C. From these two simultaneous equations we can solve m as well as C. So subtracting one from the other, we get 0, 2, 4 is equal to 500m, leading to m is equal to 420 division 500. That equals 0.84. Substituting that into the second equation, we have 680 equals 0.84 bracket 300 plus C, leading to C equals 680 minus 0.84 times 300, that is equal to, these values together in the y function, y is equal to 0.84x plus 428, which is what the question wanted us to show. Part C. With reference to the model, interpret the significance of the value 0.84 in the equation. So you can see from the equation that 0.84 is the gradient or the rate of change when one value of x changes. That means it represents the marginal cost of making 1 bar of soap. So let's write pounds 0.84 represents the marginal cost of making 1 soap. Part D. Assuming that each bar of soap is sold on the day it is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit for that day. So we know that the selling price is equal to pounds 2. Therefore it is pounds 2 times x. And the cost price, there is a function for that, y is equal to 0.84x plus the fixed cost 428. Therefore, to make profit, this pounds 2x must be greater than 0.84x plus 428. Therefore, 1.16x should be greater than 428, which translates to x should be greater than 428 division 1.16, and putting into the calculator I get this as 368.96, and hence x should be greater than this. As x should be greater than 368.96, x should be 369. That's the minimum number of bars to make profit for the factory for the day. Let's write bars. Question 8. Find the value of sigma r is equal to 4 to infinity of 20 times 1 over 2 to the power of r. So let's write the first 3 terms of this summation so that we will know what type of series this is. So this summation can be written as r is equal to 4 to infinity of 20 times 1 over 2 whole to the power of r equals 20 times 1 over 2 to the power of 4, add 20 times 1 over 2 to the power of 5 plus 20 times 1 over 2 to the power of 6 dot dot dot, and the last term will be infinity. So this is a geometric series A equals 20 bracket 1 over 2 to the power of 4. Common ratio R is equal to 1 over 2. Using the formula for sum to infinity when R is less than 1, it's equal to A over 1 minus R. Substituting these values here, 20 half to the power of 4 over 1 minus half. That's equal to 20 times 1 over 16. In the denominator, it's going to be 1 over 2. That is equal to 20 over 16 times 2 over 1, which is equal to 40 over 16 is equal to 2.5. Part 2. Show that sigma n is equal to 1 to 48 of logarithm to the base 5 of n plus 2 over n plus 1 equal to 2. So let's write the given equation here. Sigma n is equal to 1 to 48 of log to the base 5 of n plus 2 upon n plus 1. Okay, this can be written as sigma n is equal to 1 to 48. Using the logarithmic rules, we can put this something minus something, right? That is n plus 2 minus log to the base 5 of n plus 1. So everything within the sigma sign. This equals log to the base 5. First term is 1 plus 2 is 3 plus second term 2 plus 2, 4, and so on. Dot dot dot. Let's write the last term also for the first part. That's going to be log to the base 5 of 48 plus 2, 50. That is log to the base 5 of 50. From this, we have to take out the second part. Writing that also, we get log to the base 5 of 1 plus 1, 2, plus log 3 to the base 5, plus log 4 to the base 5, and so on, until the last term is log to the base 5 of 49. Most of these terms will cancel out, and the remaining terms are log to the base 5 of 50, take away log to the base 5 of 2. It's quite easy now, so we can write log to the base 5 of 50 over 2, which is log 25 to the base 5, which is equal to 2. Question 9. A research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log d to the base 10 against log v to the base 10 were plotted. The results are shown below together with a data point from each graph. Explain how figure 6 would lead the engineer to believe that the braking distance should be modeled by the formula d equals kv to the power of n, where k and n are constants with k approximately equal to 0.017. The second graph is a linear graph, and therefore our strategy should be to write this in the form of y is equal to mx plus c, and then remove the logarithms and write it out as d is equal to kv to the power of n. From the second graph, therefore, we can write log d to the base 10 equals n log v to the base 10 plus a constant c. Right, and therefore we can write that log d to the base 10 equals n bracket 0 minus 1.77, because from the graph we can see when the x value is 0, log d to the base 10 has a value of minus 1.77. Therefore, the equation now becomes log d to the base 10 equals n log v to the base 10 minus 1.77. Let us now try to remove the logarithm. Therefore, we can write d equals, the base 10 comes to the other side with everything there going as an index, n log v to the base 10 minus 1.77, which can be written as d equals 10 to the power of, let's bring this n as an index of v. Therefore, we will be writing this as log v to the power of n to the base 10 and then times 10 to the power of minus 1.77. Since 10 to the power of log to the base 10 is equal to 1, we could write d equals v to the power of n times 10 to the power of minus 1.77, which is actually v to the power of n times 0.017. Therefore, this is in the form d equals kv to the power of n, where k is equal to 0.017. So d equals 0.017 v to the power of n. Part B. Using the information given in figure 5 with k equals 0.017, find a complete equation for the model giving the value of n to 3 significant figures. So this was part A here. Now let's look at the first graph. Here there is a data point which shows when x is 30, y is 20. Therefore we write at 30, 20, 20 equals 0.017 times 30 to the power of n, right? Therefore 20 division 0.017 equals 30 to the power of en. Now taking log on both sides, we could write log 20 over 0.017 equals n log 30. Therefore n equals log 20 over 0.017 over log 30, and that's coming to 2.07876 from the calculator. So we can write this as 2.08 to 3 significant figures. So we could write the model as d is equal to 0.017 v to the power of 2.08, or in the logarithmic form we can write log d to the base 10 equals 2.08 log v to the base 10 minus 1.77. So both are acceptable ways of writing the same equation. Part C. Sean is driving this car at 60 km per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. So the strategy for this question is, we will find out the total stopping distance for Sean using the model that we have, and if it is more than 100 meters, then he is not going to be able to stop before reaching the puddle, or if it is less than 100 meters, he is going to be successful in stopping before reaching the puddle. But in the process, we should also consider the fact that there is a thinking distance here, that is, the distance traveled by the car in 0.8 seconds when he is able to react for applying the brakes. So the total distance will be braking distance plus the thinking distance. So let's start by saying stopping distance equals thinking distance plus braking distance. So thinking distance is equal to what? The car is going at a speed of 60 kilometers per hour. So 0.8 seconds times the speed, which is 60 kilometers, is 60,000 meters. But we have to convert that into per second. That is, divide by 3,600, and that gives us 13.33 meters. So let's hold that there. Braking distance is as per our model. Is equal to, we have this kv to the power of n, which is distance equals 0.017 times 60 kilometers per hour to the power of 2.08. That gives us 84.92 meters. Therefore, total distance equals 84.92 and 13.33, which is equal to 98.25 meters, which is less than 100 meters. Therefore, Sean will be able to stop before the puddle. Question 10. Figure 7 shows a sketch of triangle OAB. The point C is such that vector OC is 2 times OA. The point M is the midpoint of AB. The straight line through C and M cuts OB at point N. Given that vector OA is equal to small a and vector OB is equal to small b, find vector CM in terms of A and B. Let us draw the sketch here once again, because it will help to have the sketch nearby to our answer. Let this be vector OB. Let me draw this. Let's call this as A, and this as C, and this as, this is B, O, and this is the midpoint M of AB. And the question says that the line from C meets AB at the midpoint and goes on to meet OB at point N. Vector OB is equal to B. Vector OA is equal to A, and AC is also equal to A, because OC is 2 times of OA as per the question. Right. Now we need to express CM in terms of A and B. And since CM is passing through the midpoint M, it may be easy for us to write vector CA plus AM. And therefore, let's first of all figure out what is vector AB. So vector AB equals A to O, which is minus A, because this is A and this also is A and this is B. So minus A plus B. Therefore, vector AM equals half B minus A. Let's park it there. Now let's write vector CM equals vector CA plus vector AM. So for vector CM equals CA is equal to minus A, vector AM is equal to half of AB, which is half of B minus A, which is what we have found out here. That means this is equal to minus A plus half B minus half A. Let's also write here vector CM, because most usually I forget what we are writing after some time, because in vector questions after 2-3 steps you just miss out whatever we have been finding out. So it's always better to write the left hand side to remind us what this is. Again, vector Cm, simplifying this we get minus a minus half of a is minus 3 over 2a plus half b. So this is expressing Cm in terms of a and b. That answers first part of the question. Part B. Show that vector On equals 2 minus 3 over 2 lambda times a plus half lambda b, where lambda is a scalar constant. Just to have a strategy on what we need to do here, vector On is to be expressed in terms of a and b. So it may be better if we go from O to C and from C to N. I have captured this sketch here once again to answer part B. So let's write let vector Cn be equal to lambda times vector Cm. And therefore lambda times, we know already Cm as half b minus 3 over 2a from the answer to the previous part of the question. So let's write vector Cn here on the left, because we usually forget what we are doing in vectors after 2-3 steps. So let's keep writing the left hand side to remind us that it is vector Cn. Alright, now the question wanted us to figure out what is vector On. Right, therefore On is equal to, this is n, On is equal to OC plus Cn. Vector OC plus vector Cn. That's equal to, OC is equal to 2a plus vector Cn is what we have written here, lambda times half b minus 3 over 2a. Again, the left hand side is vector On. Cool. So expanding this, we get 2a plus lambda times half b minus lambda times 3 over 2a. Factorizing the terms containing a and b, vector On equals 2a minus lambda 3 over 2a plus lambda half b, that's equal to a bracket 2 minus lambda 3 over 2 plus lambda times half b, which is what the question wanted us to show. So that answers the part B of the question. Part C. Hence prove that On to NB is 2:1. So we need to find the ratio of On to NB and show that it is 2:1. So let's call vector On as a part of OB. So how do we write that? Let's write let vector On be, let it be another constant, let's call it as mu times OB, where mu is a fraction. So mu could be 1/2 or 1/3 or 1/4 or whatever. So we'll figure out now. Since vector OB is equal to B, we can write this as, therefore vector On is equal to mu times B. So let's call this as equation 2. The other equation containing On is equal to this expression as equation 1. So since both of them are vector On, we can equate them. Therefore we can say equations 1 is equal to equation 2. Therefore a bracket 2 minus lambda times 3 over 2 plus lambda over 2b should be equal to mu times b. There is no a term on the right hand side, but there is an a term here, which means this should be equal to 0. Therefore we can say 2 minus lambda 3 over 2 is equal to 0, leading to 2 is equal to 3 lambda over 2, or lambda is equal to 4 over 3. Since vector Cm is smaller than vector Cn, that means lambda has to be more than 1. and therefore lambda being 4 over 3 makes sense. Now let's equate the parts containing b. So on the left hand side we have lambda over 2b, and on the right hand side we have mu times b. Therefore lambda over 2 should be equal to mu. Since we already know lambda is equal to 4 over 3, we could write this as 4 over 3 times 1 over 2 is equal to mu, which means it is 2 over 3. We had assumed that vector ON be equal to mu times vector OB. Therefore, ON should be equal to 2/3 OB. Therefore, ON over OB as a ratio should be equal to 2 over 3, which means ON to OB equals 2:3, but we need ON to NB as per the question, and that should be equal to 2:1. Hence proved. Question 11. Figure 8 shows a sketch of the curve C with equation y equals x to the power of x, where x is greater than 0. Find by firstly taking logarithms the x coordinate of the turning point of C. This is too easy a question for 5 marks. What we need to do here is we should use the concept that at a turning point dy by dx equals 0. So we will differentiate y equals x to the power of x and set it against 0 and solve for x. So let's write the equation y is equal to x to the power of x. This would mean if we take ln on both sides, ln y equals ln x to the power of x, which is x ln x. We can use implicit differentiation to differentiate this function. So let's write differentiating implicitly with respect to x. We need to write this because then only it will be mathematically correct. So ln y, when you differentiate, we get 1 over y, but we also should follow up with dy by dx equals x ln x is to be differentiated using product rule. So u v dash. Are we going to take x as u or ln x as u? We could take ln x as u and this as v. So u v dash would mean ln x times 1 plus v u dash will be x times 1 over x. Therefore, 1 over y dy by dx equals ln x plus 1. So let's say at turning point dy by dx equals 0. Therefore, 0 equals ln x plus 1, which actually means ln x equal to minus 1. Therefore, x equals e to the power of minus 1, which is equal to 0.368 to 3 decimal places. Part B. The point P alpha, 2 lies on C. Show that alpha lies between 1.5 and 1.6. So this equation for the curve is y equals x to the power of x, where x is always greater than 0. Therefore, at the point alpha 2, what it means is 2 should be equal to alpha to the power of alpha, or we could say alpha to the power of alpha minus 2 should be equal to 0. The question wants us to show that alpha lies between 1.5 and 1.6. So why not we put these two values in place of alpha and see whether there is a sign change. So let's put 1.5 to the power of 1.5, take away 2 equal to, and 1.6 to the power of 1.6 and take away 2. Putting this into the calculator, we get minus 0.163 and plus 0.121. Now let's write the standard conclusion statement that yes, there is a sign change and as the function is continuous. Alpha lies between 1.5 and 1.6. That's it. Part C. A possible iteration formula that could be used in an attempt to find alpha is xn plus 1 equals 2xn to the power of 1 minus xn. Using this formula with x1 equals 1.5, find x4 to 3 decimal places. So the iteration formula is xn plus 1 equals 2xn to the power of 1 minus xn. Given that x1 equals 1.5, we need to find x2, x3 and x4. We can use the answer function in the calculator. Therefore, x2 would be 1.5 to the power of 1 minus 1.5. Putting that into the calculator, we get that is 1.633 to 3 decimal places, and pressing equal to once again, I get 1.466. The next value is 1.673 to 3 decimal places. That's a pretty easy GCSE level question. Part D. Describe the long-term behavior of xn. So looking at each term in this sequence, we can see that they keep on increasing and decreasing, and therefore they will never be convergent. So we could very safely say that this is a divergent series. This sequence forms a divergent series. Question 12. Prove cos 3 theta over sin theta plus sin 3 theta over cos theta equals 2 cot 2 theta, where theta is not equal to any multiple of 90 degrees. Naturally, because in that case, cos theta in the denominator would become 0. Let us rewrite the equation as cos 3 theta cos theta plus sin 3 theta sin theta all over the common denominator of sin theta cos theta. Okay, so this numerator follows the trigonometric angle expansion formula, which is, if we remember, cos of A minus B should be equal to cos A cos B plus sin A sin B. And the denominator follows sin 2A equals 2 sin A cos A. Using these two identities, let us try to solve this. So the numerator would become cos 3 theta minus theta, and the denominator will become half of sin 2 theta. That is half sin 2 theta. This follows cos 2 theta over half sin 2 theta. Let's look at what we need to reach. We need to get 2 cot 2 theta. Let's now rewrite this as cos 2 theta times 2, which comes from the denominator half, over sin 2 theta. So cos 2 theta over sin 2 theta is cot 2 theta, and with this 2 it becomes 2 cot 2 theta. That's proven as required. Part B. Hence, solve for theta being 90 degrees to 180 degrees. The equation cos 3 theta over sin theta plus sin 3 theta over cos theta, which is the same as the first equation, equal to 4, giving any solutions to one decimal place. So we can start by saying 2 cot 2 theta is equal to 4. Therefore, cot 2 theta should be equal to 2. Hence, 1 over tan 2 theta equals 2, leading to tan 2 theta is equal to half. Hence, 2 theta should be equal to arc tan half. Therefore, the principal value of 2 theta equals 26.57 degrees. So let us park this there and let's do two things now. One, we need to adjust the limits. The question told us that theta is between 90 and 180, but we are going to solve for 2 theta. Therefore, let's adjust the limits to 180 and 360. And secondly, let's draw the 4-quadrant diagram to determine where the angles could be. So tan of an angle is positive. So tan 2 theta is equal to half. Therefore, tan only can be in the first quadrant and in the third quadrant. So let's draw this line here. Okay. So this is 26.6 degrees to one decimal place. Here also 26.6 degrees to one decimal place. Okay. So this is 0, 90, 180, 270, 0 degrees slash 360 degrees here. The limit within which we are going to solve 2 theta is 180 degrees to 360 degrees. Therefore, the only angle applicable is this one. So we can say 2 theta is equal to 180 add 26.6, which is equal to 206.6 degrees. Hence, theta should be equal to 103.3 degrees to one decimal place. Question 13. A manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell at the other end as shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has radius r meters and height h meters, and the hemisphere has radius r meters. The volume of the tank is 6 meter cubed. Show that according to the model, the surface area of the tank in meter square is given by 12 over r plus 5 over 3 pi r square. So the planning for this question should be, we will use the volume expression for the shape and set it equal to 6 meter cubed. Since there is only r here and there is no h here, from that expression we will make h in terms of r. And that formula can be substituted into the area formula, and then we can see whether we can reach here. I have captured the sketch of the shape here so that it will appear alongside our answer. Let us start by writing the volume of the shape. Volume equals, volume of the cylinder is pi r squared h plus volume of the hemisphere is half times 4 over 3 pi r cubed. And as per the question, this is equal to 6 meter cubed. Simplifying this, we get pi r squared h plus 2/3 pi r cubed equals 6. So let's multiply every term by 3 to get rid of the denominator 3. So it's 3 pi r squared h plus 2 pi r cubed equal to 18. From here, we will try to make h the subject. So we will write 3 pi r squared h equals 18 take away 2 pi r cubed, leading to h equals 18 take away 2 pi r cubed whole divided by 3 pi r square. Let's park it there. Next part is in writing out the surface area. So let's write surface area equals the bottom part of the shape, that is pi r square, plus the curved surface area of the cylinder 2 pi r h, plus curved surface area of the hemisphere at the top, that's going to be half of 4 pi r square. So simplifying this, we get pi r square plus 2 pi r h plus 2 pi r square. All in all, it's going to be equal to 3 pi r square plus 2 pi r h. Replacing the h in this equation, we get surface area equals 3 pi r square plus 2 pi r times, instead of h we will write 18 take away 2 pi r cubed over 3 pi r square, which is from the previous step that we have finalized here. Okay, now simplifying this, that is equal to 3 pi r square plus, let's cancel this pi and this pi and this radius and this square here, plus 2 times 18, 36 over 3r, minus 2 times 2, 4 pi r cubed over 3r. This r cancels this r cubed into r square. So we have surface area equals 3 pi r square minus, let me write this together, 4 pi r square over 3 plus 12 over r. That simplifies to, so 3 times 3, 9, 9 minus 4, 5 pi r square over 3 plus 12 over r, which is what the question wanted us to show. Done. Part B. The manufacturer needs to minimize the surface area of the tank. Use calculus to find the radius of the tank for which the surface area is minimum. So here we will use the concept that at minimum surface area, it will be dA over dr equals 0. So let's write that at minimum surface area dA over dr equal to 0. So let's figure out what is dA by dr here. So you got dA over dr equals, differentiating term by term here, it's going to be 10 pi r over 3 minus 12 r to the power of minus 2. This is equal to 0. Therefore, 10 pi r over 3 should be equal to 12 r to the power of minus 2, which is also equivalent to 10 pi over 3 equals 12 r to the power of minus 3. Hence, r to the power of minus 3 equals 10 pi over 3 times 1 over 12. That is equal to 10 pi over 36. Hence, r cubed will be equal to, flip this over, we have 36 over 10 pi, leading to r equals cube root of 36 over 10 pi, and putting this into the calculator we get 1.046 meters or 1.05 meters to 2 decimal places. Part C. Calculate the minimum surface area of the tank, giving your answer to the nearest integer. To find the minimum surface area, we will substitute this value of r into the area equation that we have derived a little earlier. Therefore, part C, surface area minimum equals, let's write surface area formula first. Surface area equals 12 over r plus 5 over 3 pi r square. So 5 pi r square over 3. Therefore, surface area minimum equals 12 over 1.05 plus 5 pi 1.05 square over 3, and putting that into the calculator we get 17.20 meter square, and to the nearest integer it is 17 meter square. Question 14. Use the substitution u equals 4 minus square root of h to show that integral of dh over 4 minus root h equals minus 8 ln 4 minus root h minus 2 root h plus k, where k is a constant. So basically this is an integration with substitution question. So let's write the question here to keep track of where we need to reach. So u equals 4 minus square root of h, and using this we need to show that integral dh over 4 minus square root of h equals minus 8 ln 4 minus square root of h minus 2 square root of h plus k. When we use substitution, it means we need to remove every bit of h, including the dh, and write it in terms of u. So let's start with doing like this. So u equal 4 minus square root of h. Therefore, square root of h equals 4 minus u. So let it be there. Also du by dh equals 0 minus half h to the power of minus half. Therefore, we need to remove the dh and write it in terms of du, right? Therefore, let's write du equals minus half h to the power of minus half times dh. Okay, so rewriting this in a nice way, we'll have 1 over 2 h to the power of half dh, and there is a minus sign here. Therefore, dh should be minus du times 2h to the power of half. Again, we can't have this h also, therefore we need to replace it with the u. But we have already found out square root of h is equal to 4 minus u. Let us plug that in here. So that is equal to minus du bracket 2 times 4 minus u. Hence dh equals minus 8 plus 2u du. So let's make some space here. So the given integral will be equal to, given I equals, in the denominator it's going to be u, here it should be du, and we have minus 8 plus 2u here with integral sign there. Okay, let's split this fraction into integral of minus 8 over u plus integral of 2u over u or du. Okay, right, that is equal to minus 8 over u du plus integral of 2 du. Integrating this we get minus 8 ln u plus 2u plus a constant c. But we can't have this in the answer, so we need to replace the u with whatever value we had assumed earlier. So that is minus 8 ln 4 minus square root of h plus 2 bracket 4 minus square root of h plus c. Let us look at what we need to achieve here. Have a quick look here. So we need to have minus 8 ln, that much is achieved. Okay, so let's expand this. So we are nearly there. So minus 8 ln 4 minus square root of h plus 8 minus 2 square root of h plus c. So there are two constant terms here, 8 and the c. Let's combine them. So that is equal to minus 8 ln 4 minus square root of h minus 2 square root of h plus, let's say, k, where k equals 8 plus c. That's it. Part B. A team of scientists is studying a species of slow-growing tree. The rate of change in the height of a tree in this species is modeled by the differential equation dh by dt equals t to the power of 0.25 times 4 minus square root of h all over 20, where h is the height in meters and t is the time measured in years after the tree is planted. Find, according to the model, the range in heights of trees in this species. By range here, we would mean what is the maximum height to which this tree can grow. So we know that the maximum height will be when the dh by dt will be equal to 0. That is, no further growth happens. Hence, we can set this equation to 0 and then solve for the value of t. So part B, we have been given dh by dt as equal to t to the power of 0.25 bracket 4 minus square root of h all over 20, and then say that at maximum height dh by dt should be equal to 0. That means t to the power of 0.25 times 4 minus square root of h all over 20 should be equal to 0. Here, t to the power of 0.25 is an exponential. It can never be 0. And this 20 in the denominator also won't result in a 0. Therefore, the main cause for this being 0 is 4 minus square root of h. So we can write 4 minus square root of h is equal to 0, leading to 4 is equal to square root of h, or h is equal to 16. So we can say the maximum height of the tree or these trees or the species of these trees is h being less than or equal to 16. And we don't know the initial height. Let's assume that it's also equal to 0. So it's okay if we write like this. Part C. One of these trees is 1 meter high when it is first planted. According to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures. So there are 7 marks for this question. That actually tells you how much of work will be involved in solving it. Let's first write the given differential equation. So dh by dt equals t to the power of 0.25 bracket 4 take away square root of h all over 20. In solving differential equations, the first thing that we need to do is to rearrange such that all the h terms go to one side, including the dh, and all the t terms, including the dt, go to the other side. So we can very easily write here as 1 over 4 minus square root of h dh on the left hand side equals t to the power of 0.25 over 20 times dt. Immediately write the integrals also, because dh and dt do not exist without the integral signs. We already know the integral of the left hand side, that's equal to minus 8 ln 4 minus square root of h minus 2 square root of h, and there is a k which we will move it to the right hand side, equals, integrating the right hand side, keep 1 over 20 times t to the power of 0.25 plus 1 is 1.25 times 1 over 1.25 plus, let's say this is k2. So this is k1 and that is k2. Now that means minus 8 ln 4 minus square root of h minus 2 square root of h equals 1 over 20 times 1 over 1.25 times t to the power of 1.25. Let's say this k1 and k2 net off to a new constant c, which we will find out now. The question tells us that when t is equal to 0, height was equal to 1. Let's substitute that value here. So minus 8 ln 4 minus 1 minus 2 square root of 1 equals 1 over 20 times 1.25 is 25 here times t to the power of 1.25 plus c. And the t is what? 0, right? Therefore, we can write this whole term as 0. Simplifying this, we get minus 8 ln 3 minus 2 equal to c. So let's put this c value into this equation. So that will be minus 8 ln 4 minus square root of h minus 2 square root of h equals 1 over 25 times t to the power of 1.25 minus 8 ln 3 minus 2. The task for us is to find the value of t when h is equal to 12 meters. So let's try putting that in here. Minus 8 ln 4 minus square root of 12 minus 2 square root of 12 equals 1 over 25 times t to the power of 1.25 minus 8 ln 3 minus 2. Rearranging this, minus 8 ln 4 minus square root of 12 minus 2 square root of 12 plus 8 ln 3, this is becoming a long expression here, plus 2 equals 1 over 25 times t to the power of 1.25. Making t to the power of 1.25 the subject, we can write the whole left hand side multiplied by 25, 8 ln 4 minus square root of 12 minus 2 square root of 12 plus 8 ln 3 add 2 equal to this. Putting this entire left hand side into the calculator, I get 221.28 equals t to the power of 1.25. Therefore, t should be 221.28 to the power of 1 over 1.25. That is, take 1.25th root of 221.28, and that is 75.15 years, which can be written as 75.2 years. Well, that's the end of the question paper. I hope you thoroughly enjoyed it and found that this was quite useful to you. The paper contained a lot of good questions, and my recommendation to you would be, after making a thorough revision, make an attempt to do the entire question paper afresh within set timings and check for yourself whether you are able to finish it within the time as well as at about 95 to 100% accuracy. Wish you all the best. Till the next walkthrough, bye.